All right. Imagine you are given a particular concept on periodicity. Okay, sometimes people don't know this particular thing and they tend to like just cram it, and that creates a lot of problem. But you only need this thing to know everything about periodicity. But let's go. Now, the concept of periodicity is very, very easy. But what is periodicity? So, or what is periodic table? Why does periodic table actually come about? Okay. Now, the concept, there are a lot of principles about periodicity, how we arrange elements. The first was the rule of what? The rule of triad, where they said, oh, elements should be arranged in threes. When I say triad, it means in threes. The second was the rule of octaves. But yeah, I'm not going to bore you with all of those things. I'm just going to go to the one that JAMB is going to ask you. Very, very important ones. Okay. So the first one is that the periodic table was first arranged in order of atomic weight. Atomic weight or atomic mass. Atomic weight. That was the first ways, or the first thing that we used to arrange periodic elements in the periodic table, and that person was Dmitry Mendeleev. Dmitry Mendeleev was the guy that first arranged elements in the periodic table that was accepted, and he used atomic weight. But there was a setback to that. He realized that if you look at the periodic table, if you look at the atomic mass of argon is 39.9, and the atomic mass of potassium is 39.1. Now, if you arrange this guy in order of increasing atomic weight, why is it that argon is coming before potassium? Potassium should be here, argon should be here. That's the principle, because if this is 39.9 and this is 39.1, 39.1 is lesser than 39.9. Why is argon coming before potassium? That's another problem to this. So, but this is the first guy that talk about an acceptable form of arranging elements in the periodic table. But the one that we accept is based on atomic number and atomic what? Number. And that's what Henry Moseley. Henry Moseley was the guy that arranged elements in the periodic table according to what? Atomic number. So this is the JAMB can ask, who talk about atomic weight is Dmitry Mendeleev. Who talk about atomic number is Henry Moseley. The other names I don't want to bore you, but these are very, very important thing that you have to understand. Okay. Now, what is periodicity? Periodicity is the regular or repeated arrangement of what? Elements in the periodic table. Okay, just when you follow a pattern and you take elements and you start arranging them in that pattern. So that's what periodicity is all about. So it's the tendency of elements to be arranged in a regular repeated pattern. That's what periodicity is talking about. So if you look at this, this is just a rough sketch of elements from 1 to 20. Of course, if you know how to arrange elements, or the first 20 elements, you should know the first 30. I'm still going to teach you that. That's why you have to stay tuned. So if you have not subscribed to this channel, if I have not helped you, you don't need to subscribe. But if I have helped you, I think you should, so that other people can learn, share to your friends. I think that will help them. Okay, so hydrogen to what? To calcium. So I think you should remember that song, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. That's the first 20 elements. Okay, I will teach you the first 30 soon. When we talk about transition metals, you have to know the first 30. Okay, now that's that. So now hydrogen is a group 1 and period 1. Now don't forget this here, 1, 2, 3, 4, 5, 6, 7, 8. These are the groups, and these are the what? Periods. These are what? The groups, and these are the what? Periods. So horizontal arrangement is what? Group. Vertical arrangement is what? Period. Please take note of that. Horizontal arrangement is group. Vertical arrangement is period. Now, hydrogen, there's one question JAMB used to ask: which element can fit into 2 groups? Hydrogen can either be in group 1. That's why hydrogen is not really in group 1. It's just placed at a corner. Can you see? It's placed at the corner in the periodic table, because hydrogen can be in group 1 and it can fit into group 7. Because hydrogen is a gas, and it can behave like some of the elements in group 7, like fluorine is a gas, chlorine is a gas. Note, bromine which is the next one, is the only liquid non-metal, while mercury is the liquid metal. Take note of that. So now let's go. Hydrogen can fit into group 1, can fit into group 7. Why? Hydrogen is 1. That means if you have something like this, so if hydrogen lose an electron, it's going to behave like what? Group 1 element. Abi? Don't forget, the reason why all this happen is to attain stability. That's the reason why reactions, why chemical bonding happen, is to attain stability. That's why marriage is like a form of bonding. So if you marry, it's because you want to attain stability. So that's the way chemistry. So we actually understand chemistry. That's why the concept of marriage comes in. Okay, but that's by the way. Now hydrogen. If hydrogen also gains one, this hydrogen. Hydrogen is one. This protium. They are isotopes of hydrogen. Abi deuterium, protium. Abi, don't let me bore you with all of that. So let's move on. Now this the one that is most that we use. You understand? So this one that has this. Okay. So this is number of what? The mass number here, and this is what? The atomic number. So mass number is now number of neutron plus what? Proton. Okay. You should know that. But I don't want to. Let's just move. That's why the neutron here is what? 0. Because if the number of proton is 1, 1 plus 0, 1. So we have other isotopes, 2, 1. Then we have 3, 1. This is what they call heavy water. Deuterium. This is tritium. This is protium. Because 1, 2, 3. You have to know that. Okay, let's leave. Now, if hydrogen is equal to 1, that means if hydrogen, here, if you gain 1 electron, you become stable, like you become okay. Abi? Because here it has lost 1 electron. And I told you that it's only in chemistry that when you lose electron, you become positive. And this one alone is what we call proton. It's what we call what? Proton. Because it has lost what? 1 electron here. Do you understand? So we call this proton. Now, so also take note of something. That here it has also gained 1 electron. And now this one now looks like what? Group 8 or group 0. Don't forget that group 8, we don't call them rare gases again. We call them what? Noble gases. Now, if it's because you don't understand why the word noble gas, what it means. Noble gas means that elements, if someone tell you that you are noble, what does it mean? It means someone wants to be like you. You're a noble man. You're a noble person. That's what happens. Every other element in the periodic table wants to be like group 8. That's why group 8 elements are called noble gases. Why? Because they form what? Either a duplet shell or an octet shell, complete shell. So that's why. So everybody wants to be like them. So if this guy actually gain an electron, then it becomes something like this. So it's acting like group 7. So hydrogen can be either group 1 or group 7. So it's the only element in the periodic table that can fit into 2 groups. That's why it's placed at a corner in the periodic table. And why is it not placed as metal? It does not. It has some properties of metal, but it's a gas, and metals are not gas. Then here, some of them are gases. Can you see? So that's why it can fit into this place too. So that's one thing that you have to take note of. Okay, very very important. Now this thing is very very important. Let's talk about it. Hydrogen, helium, right? Then this is lithium. That means if I want to draw lithium, because this is 1, atomic number 1, atomic number 2, atomic number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Those are the atomic number. Okay. Now, let's say I want to write lithium here. Lithium is what? 3. That means if I want to write the electronic configuration, I'll write 2, 1. Right? That means eventually I have something like this, 2, then I have something like this, 1. So this is what they call the KL shell. Okay? That means the outermost shell here is what? Plus 1, or is 1. So if this guy loses an electron, it will become Li plus. Just like I said, in chemistry, if you lose an electron, it becomes positively charged. Take note of that. So if I want to write for 13, aluminium now, you see aluminium will be what? Because it's 13, I'll write, it will be 2, 8. 2 plus 8, that's what? That's 10, then plus 3. So if I want to draw it, 2, then I'll draw this as 8. Then I'll draw the last one, which is what? 3. Okay, so this is aluminum. So aluminum can easily lose these 3 electrons. That's why aluminum will now be what? Al3 plus. Now, if aluminum lose these 3 electrons, it becomes what? Do octets. So it's resembling group 8. So that's the concept of that. Please take note of that. Very, very important. Very, very important. Now, these are what we call properties of periodic table, periodic element. That is, they tends to. And why do you even use the word periodic? I used to use this to explain. Periodic is a cycle. Abi, period, a cycle. So that's why if you go like this, boom, you come here, you see fluorine. You go again, you see chlorine. You go again, you see bromine. You go again, you see iodine. So, like, it's a cycle. Okay. Now, this is the major thing. These are the properties that elements in the periodic table tends to have. Atomic radius, ionic radius, metallic properties, ionization energy, electronegativity, electron affinity. These are very simple concepts and you have to understand it. So let's go. Now, atomic radius. Atomic what? Radius. Now, let's say for instance, I want to write sodium. Okay, sodium here is what? 2,8,1. That means if I have this, then let's say I have this. So this will be 2, this will be 8, this will be 8, then this will be what? 1. That means I can tell you now that this is the center. Then that means if I have this to this place, just like a cycle, then this to this place. That means this is a radius, this is a radius, and the whole two radii, is called what? Diameter. That means diameter is what? 2r. Then the radius is d over 2. This is very, very easy. Pay attention. Okay. Now, this is an atom. This is an ion. But because it's positive ion, we call it what? Cation. The word cation means cathodic ion. Now, cathode themselves, they are what? They are negative electrodes. So when we say cation, means ions that go to the what? To the cathode. Now, if you are negative, what will come to you, just like as I'm a guy now, for instance, what will come to me is the negative. So I'm positive, negative comes, right? Do you get? So if this guy is cation, it means it's cathodic ion. That means it goes to the cathode. Do you understand? So if you are cathodic ion and you go to the cathode, you yourself, you must be what? Positive. That's why they call them. An ion means anodic ion. So that means these guys go to where? Let's say, for instance, Cl minus. This is an anion. So they go to an anode because anode itself is positive. So they are negative. That's why electrophiles, neurophiles. I will tell you about electrophiles means what? Electron loving. Neutrophile means positive loving. I will still teach you about that. So that's why you have to stay tuned. If you have not subscribed, if I have not helped you, don't subscribe. But if I have helped you, subscribe. Now. Do it now. Okay, let's go. So, atomic radius. Now, that means this is sodium. For lithium, how will it be? 2, what? 1. That means how many shares will lithium have? Just 2. For the next one, which is what? Potassium. Potassium is what? 19. So it will be 2,8, Abi? 2 plus 8. That's then another 8, then 1, Abi? 2, 8, 8, 1. That's 18, 19. That means the shell of this guy will be how many? 4. 4. 4. 1, 2, 3, 4. So this is where the 1 will be. So this one we have 8. This one will have 8. This one will also have 8, Abi? This one will have 8. Then this one will have 2. Now, what am I trying to say? That means the radius here of potassium will be greater than the radius of potassium, will be greater than the radius of sodium, and it will be greater than the radius of what? Lithium. The radius of lithium. The radius of lithium. Now, what do you see there? What do you observe? That means as you go down the group, this is group. The what? The atomic radius increases. That means if I go like this across the period, the atomic radius will decrease. Atomic radius now, atomic radius. So because you can see it, we are using group 1 element to observe here. Can you see group 1 element that we are using? This is 2, this is 3. So going down the group, this is the way group goes. This is the way period goes. This is group, this is period. So going down the group, atomic radius increases. Don't you see? The number of shells here, and that's the way to note period. 2881. I mean, what period is this? Period 4. 1, 2, 3, 4. Group what? Group 1. The last one here. 2, 1. Period what? Period 2. 1, 2. 2, 1, 2, 3. That's 281. Period what? Period 3. Come and see. Lithium is in period 2. Sodium is in period 3. Potassium is in period 4. How do you know the group? What is at the outermost shell? These are the groups. Okay. Now, atomic radius increases down the group. Down, as you are going down the group. Down the group. Abi? That means across the period, they will decrease. It is only one factor that will increase as you go across the period and across down the group. That's what? Atomic number. Because that's the way we arrange elements. But all of these properties, if one is going increasing across the period, the other one will decrease. It will decrease across down the group. Take note of that. Can you see how big this guy is? Atomic radius. Radius. Why are we using atomic radius? Is that these are atoms, not ion. So if I'm talking about the size of this sodium ion, what am I going to say? Ionic radius. Very easy. Very easy. Very easy. Please take note of this. If you understand this, let's move. Please take note. Right, jot this. Atomic radius decreases across the period. This is P. Then increases down the group. Take note of this. Let's move to the next one. Now, the second property is what? Ionic radius. The second property is what? Ionic radius. Ionic radius. Now, I don't know why you cram it. Look at it. Ionic radius. That means I'm only considering ions like this. Now, don't forget, if Na is 2, 8, 1, this one means it has lost one electron. That means this will be 2, 8. Yes. The only difference, this will still follow atomic radius. The only difference that I will be talking about ion. That means potassium, if potassium is 2881, so potassium plus will be what? 288, because it has lost one electron. Lithium, if it is 21, lithium ion will be what? 2. Eventually, this guy will be like this. 1, 2, 3. This one will just be 1. This is the nucleus. This one will be what? 1, 2. Don't you observe that still potassium is still greater than this? That means potassium ion, the radius of potassium ion is still going to be greater than the radius of sodium ion. It's still going to be greater than the radius of what? Lithium ion. So also in terms of ionic radius, this is across the period, down the group. So down the group is also increases. Across the period, it will decrease. Now, why is that happening across the period? Look at this. The more you go this way, for instance, let me compare lithium and fluorine. Let me give you one so that you're able to follow very well. Now, lithium is 2, 1. Fluorine is what? What is the chlorine is 9. That means 2, what? 7. Now, if you draw this guy, you see that this is 1, then only 1 electron. But here it is what? 1, 2 electrons. Abi? 2 electrons. This is, sorry, like 2 shells. But 1, 2, 3, 4, 5, 6, then 7. Now, don't you observe that in terms of size, this one will move closer because there's a force of attraction between the positive nucleus and the negative shell. These are negative. Electrons are negative. So there will be more force binding the nucleus and the outermost shell. So this one becomes closer, smaller. This one is just 1 electron. So the force between the nucleus and this will be smaller compared to this. Do you get? That means it requires more energy to remove this one. That's ionization energy anyways. I will still talk about to remove electrons here than this one. I will still talk about that. I just wanted to get something. So in terms of ionic radius, what happened across the period? This is across the period. This is down the group. So across the period, it will what? It will decrease. Down the group, it will increase. I'm going to be using majorly group 1 and 7 to be explaining this concept so that you don't get bored. Once you know whatever affects these guys, we also have effect on everything. Whatever affects group 1, we have effect on everything. So that's it. Number 2, the number 2 properties. I'll give you a mnemonics. So if you stay tuned, you get the mnemonics. Number 3, metallic properties. Of course, this one is like a rule of thumb, Abi, because you should know something that group 1 elements are called alkaline metal. Group 2 are called what? Group 1 are called alkaline metal. Group 2 are called alkaline earth metal, right? Group 3 are group 1 are called alkaline metal. Group 2 are called alkaline earth metal. Group 3 are called boron family. Group 4, carbon family. Group 5, nitrogen family. Group 6, because it's oxygen, sulfur, they are the guys that form oils. So we call group 6 all formers. All formers. So we call them chalcogens. Chalcogens. I need to write this one because UI asks it. Group 7, they form salt. So we call them salt formers. So the word salt formers means they are what? Halogens. That's why they call them halogens. Do you understand? Group 8, I already told you, we call them what? We call them noble gases, not rare gases or inert, because there's something called xenon fluoride. So xenon is a member of group 8 and is found to be reactive. So why do you call them inert? Why do you call them rare? Why do we call them? So we call them the one that is most, that we call them now is noble. Everybody wants to be like them, so they are noble. We know. Okay? So now let's go. Take note of that. The next one is metallic properties. Metallic properties. This one is common knowledge because you will agree with me that francium is the most reactive metal. Is down. After cesium is francium. So let me say cesium, francium. Now, reason why people don't talk about francium is because it's radioactive. So if you see cesium in the option, you pick it. But if you see cesium and francium is the answer. But we see in JAMB they put cesium. So they say the most reactive metal is dash. So you pick cesium. But so that means as you are coming down the group, what happens to the metallic property? It increases because francium is even below all of these guys. So it is the most reactive. Abi? Just like you can see, followed by cesium, potassium. So I don't need, because it's metallic properties I'm talking about. So that means the most electropositive element is what? Francium. Abi? Just like fluorine is the most electronegative element. That means if you know that, something happens. That means you don't need to cram. If francium is the most electropositive, fluorine is the most electronegative. That means FF, the way to know them. So you don't need to miss them. Francium for metals, fluorine for non-metals. Okay? Take note of that. That's what we are going. So that means down the group, across the period, down the group, what happens? Because I'm using this one, that means metallic property increases. Why across the period it what? Decreases. So you don't need to cram too much. Now, what did you observe? 3 things decrease across the period. What are they? Atomic radius, metallic property, and ionic radius. So that's why we use the word DAMI. DAMI means, D here means decrease across the period. That's what it means. So when you decrease across the period, what are things that you don't need to know 2 things, just know 1. That means if atomic radius decrease across the period, it will increase down the group. If metallic property decrease across the period, it will increase down the group. If ionic radius decrease across the period, it will increase down the group. So just know 1 because of these mnemonics. So you'll be able to know the other one. Decrease, Dami. That's my name. I'm Damila Redo, Dami. So decrease across the period. Atomic radius decrease across the period. Metallic property decrease across the period. Ionic radius decrease across the period. So that's for this. Okay. Now let's do another segment of this particular thing is when we want to consider the fact that some other properties like ionization energy, electronegativity, electron affinity. So this is the first one, the DAMI. Take note of that. So let's move to the second segment. Okay, now, so the second one here, which is the fourth, is ionization energy. This is where people don't get these things very well. Ionization energy. Look at it as an energy, not ability like electron affinity. I'm not rhyming anyways. Okay, so ionization energy is the energy required, or is the amount of energy required to remove the most loosely outermost electron. Now look at it. I'm going to be considering, of course, whatever happens, if you are considering a particular period, you have to consider it fully, like this period, consider it. So let's say I'm considering Ni and fluorine. Ni is 3, fluorine is 9. So this is what? 2,1 and this is 2,7. If I draw this guy, I'll have something like this. This is 1, then I have this. Then if I draw this, I have something like this. This is 2, then this is 1, 2, 1, 2, 1, 2, 1. Yes, that's why sometimes there's something called first ionization energy, second ionization energy, third ionization energy. Now look at it. The ionization energy here, just to remove this electron, right? If you want to remove this electron, that's why this one can easily go to Ni plus. So because if I remove this electron now, it will turn to this. But look at fluorine. To remove this electron is going to be hard. Why? Look at it. There are a lot of electrons. And don't forget, the nucleus is positive, right? So that means there is so much electron that will pull this guy towards the center. So the energy that is required to remove this electron in the this is the outermost shell of fluorine. In the outermost shell will be greater than the one that we use to remove this electron in the outermost shell of lithium. So that's why I will tell you that the electron energy will what? That means if you are moving across this period, what do you think it will happen? It will increase across the period because this one has more ionization energy than lithium. Definitely, neon will have more ionization energy than fluorine. Do you understand? So fluorine is higher than this, oxygen is higher than this is higher than this is higher than this in terms of ionization energy because they have more electron in their outermost shell. Okay, very, very important. There are a lot of concepts about shielding effects, the concept of screening and shielding effect, but I'm not going to bore you with so much stuff. Just take note of that. Very simple. I just want you to get it very well. Electrons here, they pull. There's a form of attraction. These are positive, these are negative. So it will be hard for you to remove electron. Okay, so the ionization energy, which is the energy to remove the outermost electron, the loose electron. Because this one, the first ionization energy, after this one, that's all. And if you look at this, these are an electron, an electron, an electron, an electron, an electron, an electron. There's also an electron here. So there tends to be more force for you to take it up from there. So take note of that. Now, let's say we want to consider sodium. Sodium is 2,8,1. Chlorine is 17, 2,8,7. Look at the outermost electron. It will be so easy. The energy here will be small. Energy is so small. But the energy here, look at, there are 7 electrons. The energy here, this is just 1 electron. The energy here will be higher. So you think of first ionization energy, just remove the first one. Another ionization energy to remove the second one. Third ionization energy to remove the third one. So that means you expect that chlorine should have a greater ionization energy than sodium. So across the period, ionization energy increases because this one is greater than this. Do you understand? So down the group, what happens? It decreases. That's why fluorine has more ionization energy than chlorine. And that's why fluorine is also the most electronegative element. So that, please take note of that. So in terms of ionization energy, what do you say? Down the group, across the period. So it increases across the period, then down the group, it's what? It decreases. Take note of that. Very, very important. Now let's move to the second one, like in this category, is what? This one, you should know this, is electronegativity. Electronegativity. Of course, you should know that fluorine is the most electronegative element. It's the most electronegative element. So that give it away. If fluorine is the most electronegative element, and what is the most electropositive? I told you francium. Abi, francium is the most electropositive element. Fluorine is the most electronegative element. Absolutely. That means down the group, francium in terms of electronegativity, down the group it will decrease, right? Across the period it will increase because this is electronegative. This is the most electronegative. So that one does not really require anything. You don't need to. There are when we talk about the potentials, electropotential, and all of them. I don't want to bore you with that, but just take note of that. Fluorine is the most electronegative element, so that gives it away. That means if you are going like this across the period, electronegativity increases. Down the group, electronegativity decreases. So it also follows this in terms of what? Electronegativity. I don't want. There are a lot of electronegativity. But these are very, very important concepts. Take note of that. The other one, the thing I did not mention that you have to also take note that there must be in gaseous state. There must be in gaseous state. But let me talk about electron affinity. I will emphasize that gaseous there because it's very, very important. If you take note of this, that means you can see now this electron affinity. The reason why I would emphasize this here, you will see it now. Electron affinity is not the energy. When you say affinity, just like it's English, it means love. You love something. So electron affinity is the ability of an atom in its gaseous state, right, to gain an electron to itself. You understand? An atom in its gaseous state to gain an electron to itself. Or sometimes they say a molecule because you want to believe that something like chlorine gas now, it exists as a molecule, not an atom. And you must be in gaseous state to gain an electron. This is an electron to now produce a negative atom also in its gaseous state. Ability of a molecule, like in this case, to gain an electron to produce. Of course, I told you that when you gain an electron in chemistry, when you gain something and you gain this electron, you'll be negative. It's only chemistry that is like that. You know, normally when you gain something in real life, you should be positive now. You gain, you should add. But because you are gaining something that is negative, so if you gain something that is negative, you will eventually turn negative. Why? Look at this. Chlorine gas, the original state here is 0. Like the state here is 0. Then this one is what? Because electron is negative, so you have -2. This is plus times -2. So this is what. So eventually you are having something like this. 2 -2 again, because 0 - 2 will give -2. That's why you have something like 2Cl-. Do you understand? So that's the idea. Can you see? So there must be in gaseous state. It's very, very important. So now that means look at fluorine also. Fluorine will have more electron affinity than lithium because it wants to gain an electron. Do you understand? Because look at, let's say for instance, lithium now. This one 2,1. If lithium gain 1 electron, is okay. Let me use something like, because this is chlorine. Let me use the same period, chlorine and sodium. This is 2,8,1. If this guy gain 1 electron, it becomes Na-, and eventually this one becomes 2. No, it was 1. When you gain 1 electron, it becomes 2,8,2. That's nothing happens. Like it's not really a big deal. But if chlorine will be more happy. It will be more happier than, what's it called? Okay, this is 2,8. This is 8,7. So chlorine will be more happy to gain an electron, such that if you gain 1 electron, you become 2,8,8. That's what I love. That's what I love doing. 2,8,7. So if you gain 1 electron, it becomes 2,8,8. That's my niche. That's chlorine niche. That's what it loves. That's what it loves, because this one it loves giving out. This one it loves losing, so that it can be complete. I told you that the basis of these reactions, this losing of electron and all of that, is to attain stability. So if you want to attain stability, you will prefer to lose 1 so that it can become 2,8, than to gain 1 so that it becomes 2,8,2. Now here you prefer to like gain an electron so that it can become 2,8,8. So electron affinity for group 7 now, for instance, that's why fluorine, which is 9, 2,7. When chlorine gains 1 electron, it becomes 2,8. That's okay. That's what I love. Unlike other ones here, like lithium, 2-1. If this guy gain 1 electron, it becomes 2-2. Yes, it's okay, but that's not what it loves doing. This guy loves to what? To give out. Do you understand? So that, please take note of this. So what do you see? What do you observe? That means as you are going across the period like this, fluorine is more, it has more electron affinity than these guys because it loves accepting. Affinity is the love of electron, not giving. That's why sodium that is 281. The thing is, I mean, electron affinity means to accept, to love. These guys, they don't love accepting electron, they love giving out. They are givers. Chlorine, halogens like these guys here, they are what? They are lovers of electron affinity. So this is not their thing, it is this guy's thing. So that's why fluorine, I told that fluorine is a point of target here, so that you understand. So fluorine now, we what? We love accepting, and it's the most electronegative, just like we said. So that means as you are moving, so the same thing for electron affinity. What is important is that it must be in its gaseous state. This thing is very, very important. So affinity, across the period, it will increase. Down the group, it will also decrease. So those are the 3 concepts that you have to understand. So what is the mnemonics? What is the magic? I hope you understand this. Very, very important. So let me give you another one. So if you have something like F minus, if you have not subscribed, if I have helped you, please subscribe so that I share to your people and all your students, your classmates, your everywhere. But if I have not helped you, you might not need to subscribe. But yeah, please, yeah, do it, subscribe. So let's say fluorine gas gains 2 electrons to give what? F minus 2. Okay, gaseous. Can you see? It loves accepting. Unlike sodium, that loves giving. Loss of electron. This is gain of electron. This is loss of electron. Do you understand? So another way I can write this, maybe some of you in your textbook. Another way you can write this is that when you take this minus A, this one becomes Na, then minus electron to give what? Na plus. So this is like losing the electron, gaining the electron, losing the electron. So this is another way to write this. It's just so if you want them to be on the same side like this. Can you see? So this also means you are losing because it's negative. Forget about the electrons are negative, but it is not what? Negative. Do you understand? So please take note of that. So that's why if you now do plus, this is minus times minus, it becomes plus. Do you understand? So okay. So I think that's by the way. So you can do it that way, you can do it the other way. So just take note of that. I just wanted to note this. Very, very important. So now let's go. All these ones are just ways for you to understand some things and all of that. But what is the mnemonics? Is I square E square. What does I square mean? I square means double I. E square means double E. So it means increase. That means, you know, we are using the across the period for the first one. It's also across the period. So as you go across the period, ionization energy, electronegativity, and electron affinity, they all what? They all increase across the period. So if you go like this, they all increase across the period. So that's the meaning. So the full mnemonics to know this is this. Dami, my name, equals to I square E square. Now don't forget, I already told that the I square means I, E, E. So that means decrease across the period. Decrease across the period. What are the things that decrease across the period? Atomic radius, metallic property, and ionic radius. They decrease across the period. What are the things that increase across the period? Don't forget, the 2 is always across the period. Across the period, the 2. That means, so across the period, what are the things that increase? Ionization energy, electronegativity, and electron affinity. Those are the things. But what is the thing that increase across the period and also increase down the group? What is it? Atomic number. Atomic number. And who arranged elements in periodic table according to atomic number? Who is that? Henry Moseley. Take note of that. Very, very important JAMB question. So that's the most acceptable and the efficient way of classifying elements in the periodic table. I hope you can do something. See you in the next class. Bye.